There we go.
Well,
Well, happy Wednesday evening to you all who are tuning in to watch us tonight, either in our live Zoom classroom or on our YouTube live stream. Welcome. Glad to have you with us. This is a ham radio class. We're teaching about amateur radio, and the goal is to convey the knowledge and information necessary to pass a 35-question multiple choice test to get your amateur radio license in the United States. And after tonight, we will be over halfway through the class. We're going through a lot of information tonight. We've gone through the past nights, so it's going to get easier as we go along. Folks, I hope you've hung in there and you've had some aha moments. That's the kind of thing that we like to have. So this is the book that we use. We're on chapter 5 tonight of this book, the American Radio Relay League License Manual for Technician Class, the 5th edition. And it has all of the questions and answers, and we go chapter by chapter each week here on Wednesday nights. So happy to have you along with us. So let's go ahead and get started. The chapter title is Amateur Radio Equipment, and if you're a nerd like me, you kind of like to push the buttons and turn the knobs and whatnot. I want you to start thinking about radio frequencies and radio as a spectrum of information, and the visible light spectrum from the infrared to the ultraviolet, from the red to the blues. Well, radio frequencies are on a spectrum as well, and we've talked about high frequency and very high frequency and ultra high frequency. And so what you're looking at here is a spectrum display. Let me turn on my laser pointer. If I get my cursor back over here. So we're looking at amplitude of signals on the vertical scale and frequency on the horizontal scale. So we're looking at a spectrum, and each one of those radio signals is there for a reason. It's there to convey information. And the way that we put information onto a radio frequency carrier, whether it be radio or television or digital signals, is something called modulation. Modulation is adding information to a radio waves, and it can be just as simple as turning the radio wave on and off in a pattern that is recognizable at the other end, Morse code. So here we have a Morse code key, and using this known pattern, you can send text messages and other information from point A to point B. So it's called continuous wave, Morse code transmission on radio. It had to do with, back in the day, they used spark generators and things like that. And when they came to Morse code, they were using electronic oscillators. So that was called a continuous wave. It's abbreviated as CW. And CW transmissions in the past were said to go the farthest for the amount of power that would be used. Now, there's a new mode, we'll talk about it, that actually goes a little bit farther even than Morse code. A CW transmitter emits energy on or about one frequency, and just turning that transmitter on and off generates bandwidth signals on the left and right of the center carrier frequency. So this is the frequency that the transmitter might be tuned to, and turning it on and off with the Morse code actually provides some information off to the lower side and to the upper side. These are, we call them side bands. And here's an actual spectral display of a Morse code signal during the transmission phase, and you can see that it has a bandwidth of about 150 hertz. That's the total bandwidth of the signal from lowest side band to the upper side band. That's the space that the signal occupies. Well, what about voice? Amplitude modulation was the first type of modulating signal to allow voice transmission on radio frequency carriers. And what you have is a modulating signal, voice. In this case, we're looking at a sine wave. And the radio frequency carrier's amplitude, its strength, is being changed in concert in synchronization with the audio. The audio modulates the radio frequency carrier. And so what we're looking at here is in the time domain. This is an oscilloscope view if you connected it to the output of an AM transmitter. Amplitude on the vertical scale and time on the horizontal scale. So this is what it would look like in the time domain. This is what we call the time domain. What we looked at before was in the frequency domain. And for amplitude modulation, again, we have a carrier frequency that is on all the time. And as it's varied in strength, we have the generation of lower side bands and upper side bands. So the total signal is the composite of those three things. And for communications voice signals, not broadcast, but for a voice signal for communications purposes, we say that the bandwidth is typically about 6 kilohertz. So an AM signal modulated on the ham bands would be about 6 kilohertz wide with a central carrier and a lower side band and an upper side band. Okay, I'm kind of excited. We're going to try something new tonight that we've never done before. This is the Flex Radio Maestro. It's a control surface for a radio that is operated remotely. And Bruce, if you would take the multi-signal there, here is my Flex Maestro with my reflection of the background. Do you like that? That's customized. And here we are on the 40-meter band. And I'm going to turn the audio up. If you turn the audio on the multi, please. No idea what signal this is. This is an AM signal. Let's take it a little closer. So you see the red line there in the center as it's coming up on the far display. That bottom part is coming up on the display. And up above, that's the spectral display of amplitude.
Invited to listen to Sofia Di Covanta from Bukovina in the northeast, performing a traditional roundabout song from her native region.
The lower side, and above that red line is the upper side band. So here we have something from an international shortwave broadcaster, but they're planted right in the middle of the amateur radio 40-meter band. Notice on the left-hand corner, the upper left-hand corner, it says 7.220. So this is an AM signal in the 40-meter band. Now, ham radio, we don't typically use AM. There are still some hams that do, and our signals would not be quite as wide as this one is. If you see on the top there where it says the letter A, and you see the shaded area to the left and to the right, that's about the space that a non-broadcast AM signal would occupy. But this is a broadcaster, and they're allowed to go further out into bandwidth. So this is an AM signal, and it consists of a lower side band, an upper side band, and the carrier. So if we go back to the laptop, Bruce, just for a second, and you can take that audio down. Yeah, okay. So here we have the original audio on the top indicated, and the AM with the carrier, lower side band here, upper side band. And what hams and what actually Collins Radio discovered was that if we could eliminate that carrier and eliminate one of the side bands and just transmit an upper side band or a lower side band, that we could use our power amplifiers in our radios more efficiently, and we could go farther for the same amount of power. But something to keep in mind, single sideband, which is the most common voice modulation mode in amateur radio, is a part of the amplitude modulation family. So single sideband is an AM signal, just without the carrier and without the other sideband. And the bandwidth for a single sideband signal is half that required by an AM signal. So remember, the AM signal for communications purposes was 6 kilohertz wide. Well, the single sideband signal is 3 kilohertz wide. All right, let's go back to our Maestro, the Maestro moment here, and let me select up You can go back, Bruce, and go. So we are on the 40-meter band. Put my headphones on so I can hear what's going on. You hear that? Sounds almost like a Donald Duck. So I'm mistuned. I'm not quite properly tuned.
So it kind of gives you a little bit of the flavor of what,
there we go.
You know, what goes on
That
in
is
the
a
city
ham
here.
radio signal
Of course, you
on the
understand
40-meter
it's
band.
college town.
Notice
And
it's
in
just
college
the
town, you
lower
got
side
a
band.
bunch
There
of
is no red
left-wing
carrier being transmitted.
communist Marxist,
This is a lower side band signal on the 40-meter band.
devil-loving professors. And
All right, I don't know what they're talking about, but okay. And we're below 9 megahertz. So the convention is, if you go back to the laptop, Bruce, the convention is that below 9 megahertz, we use lower sideband. Above 9 megahertz, we use upper sideband. There used to be a technical reason for this, but that's largely been overcome. But just by tradition, this is what we do. Now, there are some exceptions, and we'll talk about that. We want to know where the band edges are, not only for the top and bottom of the 20 meter or 40 meter bands, but we want to know for our license. If we come back to me just for a second, Bruce, full if you would. So here's the color chart, and if you remember that there are subdivisions here on the color chart for extra, advanced, general, and technician as to where the frequency privileges are for your class of license. So we want to make sure that we are aware of the top end of the band, for example. So we need to watch for that. All right, let's move on to frequency modulation. For the little radios, like technicians will typically start out with, the little handy talkies, these are FM, or frequency modulated radios. In here, this was the amplitude modulated signal we saw before, where the signal strength is changing. For FM, the signal strength stays the same. It is the frequency of the carrier that is changed. And I have a little bigger slide here you can see, maybe a little easier. This is an FM, or frequency modulated signal. And by changing the frequency up and down, we actually occupy a certain amount of bandwidth. And for communications purposes, FM bandwidth, we say, is between 10 and 15 kilohertz wide. So remember, we started out with Morse code, 150 hertz, thereabouts wide. Then we went to AM, or amplitude modulation, which is about 6 kilohertz wide. Then we went to single sideband, which is about 3 kilohertz wide. And now we're talking about FM signals, and these are between 10 and 15 kilohertz wide. So FM signals are much wider than any that we've talked about before. An interesting phenomenon with these FM radios is that they will, the receivers inside, will capture the strongest signal. So if there are two signals that are transmitting on the same frequency at the same time using FM, only the strongest signal is received because of something called the capture effect in the demodulator in the radio. So just something to be aware of. All right, I want to take you back into time, if you're as old as I am. And if you've been into computers, remember bulletin board systems? Yeah, that was when we were smoking with analog modems. We put the headset on the acoustic coupler there, and we were lucky if we got 300 baud. Well, back in this time frame, hams were experimenting with transmitting data over the air, over radio, and they came up with something called packet radio. Packet radio uses little radios like this walkie-talkie, and running signals into the microphone input and from the speaker output, and to a box called a terminal node controller, or TNC. And on one side you could have a computer or a dumb terminal where you could type information into the TNC. It would go from the TNC to the radio as tones, from the radio out to an antenna, and connect up to another TNC at somebody else's station. So this is packet radio, one of the early forms of digital communications in amateur radio. It still exists today, and we'll talk about that coming up here. And okay, you don't know to know the details, but this is the format of AX25. That's the protocol that is being used. And packet radio uses these little radios, which I said are FM. Sometimes it could be phase modulated, AM or FM or PM is what I want to say. So packet radio uses FM radios or phase modulated radios. What's phase modulation? Well, phase modulation is a type of frequency modulation where both the amplitude of the, let's say, audio signal and the frequency of the modulating signal affects the frequency deviation. With FM, it's just the amplitude. But with phase modulation, it's amplitude and frequency that change the modulation characteristics. And in the technician class, that's really all you need to know. But we expand further on this in the general and then extra classes. Another type of phase modulation is something called phase shift keying. This is when digital modulation process that carries information can be expanded and enhanced by not only changing the tones, but also changing the phase of the transitions. That's how modems worked to go from 300 baud up to 1200 baud, up to 2400, up to 19K, and finally up to 56K. The audio tones were still going through the same phone system. There was no additional bandwidth, but they used phase shift keying to expand the amount of information that could be transmitted within that limited bandwidth. Again, in the technician class, you don't need to know all of the intricacies, but if you'd like to find out more, Google is your friend. Frequency shift keying, I'm going to confuse myself here, is most normally associated with radio teletype. And so here is the screen from a radio, much like the Flex, where we're looking at the amplitude of signals. And you see there's a signal here, and there's a signal here. And if you were to look at this online, you would see that the signal, one is up and then the other is up. These are the mark and the space tones of radio teletype. Not space out in the air, but space on a piece of paper. It goes back to the way things were first decoded. So frequency shift keying is used for radio teletype, which is something that hams still do to this day. So just to review, we had Morse code, which for the purposes of the test we say goes the farthest for the amount of power used. Single sideband voice definitely is the voice mode that goes to the farthest. There are some digital voice modes that are being used on HF, VHF, and UHF, and they're kind of interesting. FM has the clearest voice quality. You know that from listening to FM radio in your car, for example, which is frequency modulation. Frequency modulation, PSK and FSK and digital modes can transmit text files. And packet radio, that first early data communications mode that hams used and still are using, remember, uses these FM radios on VHF and UHF frequencies. All right, we talked about bandwidth of signals for voice and for Morse code. Television. I used to work as a broadcast engineer for public broadcasting and then a commercial TV station up in Saginaw, Michigan, the then NBC affiliate. And amateur television still uses the same analog standard that we use for broadcasting. It's called the NTSC standard, National Television Systems Committee, and its bandwidth is really big. We were talking about 150 hertz, 3 kilohertz, 6 kilohertz, 10 to 15 kilohertz. Now we're talking 6 megahertz of bandwidth, because a fast scan television signal is an AM signal, believe it or not, with a carrier right here, but the sidebands are not symmetrical. It transmits a full upper sideband and a vestige of the lower sideband. Hence, this is called vestigial amplitude modulation. And there's the black and white signals there, the color signal. There may be an audio subcarrier, but just know that the NTSC television signal that amateur radio operators can use on UHF and above is going to be 6 megahertz wide. All right, we made it to some questions. So in the Zoom classroom, if you'd like to go ahead and you can unmute and tell me what you think the right answers are here. And remember our 3-second rule. Try to wait just 3 seconds before answering, so folks watching on YouTube don't, they get a chance to play along as well. So which of the following is a form of amplitude modulation?
Charlie, C.
Yep, single sideband, remember I said that's a part of the AM family of signals. And what type of modulation is commonly used for VHF packet radio transmissions?
Alpha.
That was the early digital data mode back in the day, so yeah, FM or phase modulation. Which type of voice mode is often used for long-distance weak signal contacts on the VHF and UHF bands? Which voice mode goes to the farthest?
Charlie.
Yep, single sideband, which is what I like to do. In fact, I had some single sideband contacts with Europe this afternoon. So which type of modulation is commonly used for VHF and UHF voice repeaters? Using the little radios.
Delta. D.
Yeah, it's going to be FM or phase modulation, generally FM. So which of the following types of signal has the narrowest bandwidth?
Charlie.
Yep, Morse code, the CW signals, about 150 hertz. And which sideband is normally used for 10-meter HF, VHF, and UHF single sideband communications? Remember I said the 9 megahertz was the dividing line, so 10 meters, what frequency is
Alpha.
that? Okay, the frequency is 28 megahertz if you look at your color chart. So by convention, we're going to use upper sideband on that. And we're going to be playing along with some radio activities later on in the class. We have some extra time when we go through the operating license, the operating regulations, and the licensing regulations. So we'll have time. We'll do some tuning, maybe even make some contacts here in class. So what is a characteristic of single sideband compared to FM?
C. Charlie.
Single sideband signals have narrower bandwidth is correct. They're not easier to tune in. You heard that I had it mistuned there for a while. That's what happens. You've got to, it's very finicky about tuning. And because it's an amplitude modulated signal, interference from static crashes, lightning, and stuff like that is easily heard. So what is the approximate bandwidth of a typical single sideband voice signal?
Bravo.
Yes, 3 kilohertz. Could be a little narrower, but 3 kilohertz is the standard. And what is the approximate bandwidth of a VHF repeater FM voice signal?
Charlie.
Yeah, FM between 10 and 15 kilohertz. And what is the approximate bandwidth of AM fast scan TV transmissions? Think NTSC.
Bravo.
Bravo. The National Television Systems Committee, or as we broadcast engineers always called it, never twice the same color. So what is the approximate bandwidth required to transmit a CW signal?
Bravo.
So CW is abbreviation for Morse code, and we know that the bandwidth for those is about 150 hertz. Which of the following is a disadvantage of FM compared with single sideband?
Bravo.
Because of that capture effect, only one signal can be received at a time with FM. And what is CW?
Delta.
Yes, it is another name for Morse code. All right, great. We did fine. Let me go ahead and mute you all here again. And let's carry on to section 5.2, transmitters and receivers. Sometimes people have come to ham radio from the CB world. Citizens Band uses radios with a knob that you turn, it goes click, 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 click. 40 channel CB radios. Well, for ham radio, we have what I like to call the big knob. This is an ICOM IC7300 transceiver right here. But if we go back over to the multi, Bruce, and we look at our Flex Radio Maestro, see right here? That's the big knob that we can tune. So what we can do as hams, thanks Bruce, is that we can go anywhere in our frequency band, any frequency. And you'll see that most hams will standardize on an even numbered frequency, but or with .00, but sometimes they don't, and you don't have to, because we have the ability to QSY, that's the Q code for change frequency. CB radios, FRS radios, GMRS radios have specific channels, specific frequencies, but we can change in the band. Now, on handy talkies and even on some HF radios, certainly on the old CB radios, the squelch control was important. On HTs, the squelch control is there. Come back to me just for a second, Bruce. So this is the venerable Baofeng UV5R, which is no longer imported into the United States. And I'm not going to make a transmission on it, but and we've got so many signals going on here. But right now, squelch is on so that there's no noise coming out of the radio, but there's a button on the side of the radio that I can push that turns squelch off. Do you want to be listening to that all the time? So that's where squelch comes in. And there are different kinds of squelch. Carrier-operated squelch will open up when any radio signal comes on frequency. And then there are some other private type of squelches. We'll talk more about those coming up. But squelch is something, and even on HF radios, this is an Alinco. I have this radio actually in my truck, and it's got a squelch control. So using here carrier-operated squelch. Not so much used on the shortwave or HF bands, but it's there on many radios. But mobile radios and handy talkies, they make the most use of squelch. So for 2 meters, 70 centimeters and up, you're going to want to have a radio with squelch. So I mentioned that there are different kinds of squelch. Carrier-operated squelch, which it'll open up whenever there's a radio signal on frequency. There's also called CTCSS, PL, and tone squelch, which is the name for transmitting an additional subaudible tone along with your voice. Some radio repeaters require this for access, for you to use. And this is what it stands for, Continuous Tone Coded Squelch System. Motorola called it Private Line, or PL. And there's others, the Digital Coded Squelch from Motorola. How do you know? Well, first, where to tune your radio and to what frequencies and what kind of squelch? Repeater directories. The American Radio Relay League sells a book that you can buy that has all of the radio repeaters in the United States. There's also an app for that as well. I like the app Repeater Book, which is available for Android and for iOS. It's free. So you can download Repeater Book, and it will know your location because of the GPS in your phone, and it will show you all the nearest amateur radio repeaters to you on the various frequency bands, so you can program them into your radio. So if you want to receive a very weak signal on FM, if you know that your buddy is going to be calling you on a simplex frequency, let's say not on a repeater, just on one frequency, and you want to hear that very weak signal, what you have to do is turn the squelch off. Because with the squelch on, this radio is not going to hear weak signals. But with the squelch off, and if you listen very carefully, you might be able to hear a weak signal. So the point is that if you want to hear weak signals with a radio with squelch, you may need to turn that squelch off. All right. We're going to modulate our radio carrier with something, turning it on and off, or we're going to talk using our voice, or we're going to have a computer that's going to be sending some text. So there are various input devices that aid you in modulating the carrier, such as Morse code paddles. There's a bug key up on the top here, microphones for voice applications, even keyboards or keypads for sending Morse code or other transmissions. If you're going to be interested in Morse code, it's no longer required to get your ham radio license, but it's a very popular hobby, or part of the hobby still today. You may end up wanting to get something called a paddle here and an electronic keyer. The output of this is a Bencher BY1, goes here, and you automatically, this is an iambic paddle. If you push on the left, it sends dits, and if you push on the right, it sends das, and this knows how to form those characters and send them to the radio. So that's the job of an electronic keyer. Nowadays, in modern radios, the electronic keyers are built in to the radio, so you don't even need to buy anything extra. Just your paddle, like this, and plug it directly into the radio. Speaking of plugging in, microphones, the 8-pin Foster connection, which you're looking at there on the left, is a kind of a standard connector that you see on various radios. The problem is there is no industry-wide standard. So the major manufacturers like Flex Radio, Yaesu, Kenwood, ICOM, they use the same connector, but they wire it differently. So just be aware of that. That not, you might, if you buy an ICOM microphone, it may not work with your Yaesu radio, even though it looks like it should. It might not. So just be aware of that. And there are adapters and things that are made that allow you to plug in all sorts of different other kinds of microphones or headsets into various different kinds of radio. Heil Sound, for example, makes a whole series of these adapters right here for use with headsets and radios. Now, if you're going to be a single sideband operator like I am, you're going to be concerned about the quality of your audio signal from the microphone on through the radio. And you're going to want to know that your microphone gain in the radio is set properly. It's like, Goldilocks. You see on the left there, that's too little. You see on the right, well, that's way too much. And right there in the middle, that's just right. So you want to make sure that your microphone gain is set properly, because otherwise it causes distortion and garbles the signal, and people won't understand you. Here's a nice Elecraft radio, the K3. This is the front panel of the K3 anyway. And lots of knobs, lots of buttons. And so let's talk about some terms that you'll find on all of the radios. So the big knob is also known as the variable frequency oscillator, and that sets the operating frequency that the radio will be receiving and transmitting on. Most high-frequency radios, the Flex and the Elecraft, are what they call multi-mode radios. They can send and receive amplitude-modulated signals, single sideband, Morse code, FM, radio teletype, and various data modes like FT8. They have memory channels, so if you have a favorite frequency that you like to listen to or participate in a net or something, you can put it into memory and then recall it from memory at the push of a button. That's kind of handy. Most ham radios for the HF bands are multi-band radios. They'll work on all of the amateur radio bands from 160 meters, typically up to the 6-meter band. So those are multi-band. So they're multi-mode and they're multi-band radios. And different ways of tuning the radio, well, one is recalling that memory channel that I talked about. Another way is using the big knob. And then a lot of radios have keypad entry, either on the microphone or right on the front of the radio, where you can actually just punch in the frequency that you want to be operating on. So those are all different ways that you can tune the radio. That's for your transceiver, it's the frequency that you'll be transmitting on and receiving on. Now, receivers are the heart of communications. We need receivers to have good sensitivity. That's the ability to detect a weak signal. And selectivity. That's the ability to separate the desired signal from others that might be close in frequency. So sensitivity and selectivity are characteristics that we want in a good ham radio. And for receivers, the controls, well, you might see an AF control, known as an audio frequency control. Okay, it's really just a volume control, but we have a fancy term for it, AF. Not so much anymore the intermediate gain control, but on older radios, tube-type radios, this was common. There's also passband tuning. That's common on modern radios, where you can adjust the bandwidth of the received signal to the receiver to match the type of signal that you're trying to receive. There's filter selections for narrower or wider filters. There's radio frequency gain controls, so you can adjust the input gain on the radio frequency section. Notch filters, which are used to eliminate interfering signals. And then attenuators. If you're operating close by other radio transmitters, sometimes you need to put an attenuator in so that your receiver doesn't overload. The thing that we talked about, the filters and the filter selection, we want the filter to match the transmitted bandwidth for the best reception. It gives you the best signal to noise ratio when your received bandwidth is exactly the same as the transmitted bandwidth. You're not listening too much, you're not listening too little. All right, so if you're going to get an HF receiver or HF transceiver, we want to make sure that you use automatic gain control, or you end up looking like this. Automatic gain control, it's another button on the radio. What it does is if a strong signal were to come up on frequency where you're listening, it'll reduce the gain automatically. It brings it down. Old timers back in the day used to say, I run with my radio with the AGC off. And you ask them a question, and they say, hey, what did you say? Huh? You say something? It'll affect your hearing. Don't do that. You don't want that. So use AGC. Another control on the radios is something called receiver incremental tuning, or RIT. It's a fine tuning. So you've got that big knob where you coarsely tuned in, and then the receiver incremental tuning would just adjust the receiver slightly up or down. If your buddy is on a radio that's slightly off frequency and you're on a net that has meets on a certain frequency, well, you want to make sure that you're transmitting on that frequency. You don't want to be tuning the big knob up and down all the time, so you can use receiver incremental tuning just when your buddy is transmitting, and then go turn it off when the rest of the folks are transmitting. And receiver incremental tuning, sometimes called a clarifier, also can be used to help a single sideband voice sound normal. Because remember, I said it's kind of finicky to tune, so RIT can come into play. And on receivers, you will have an S meter, stands for signal strength, S meter, signal strength, and it's calibrated in S units, S3, S4, S5, S6, S7, S8, S9, and then above that it's calibrated in decibels, plus 10 dB, plus 20 dB, plus 30 dB. Each one of these steps from like 8 to 9 is considered to be 6 dB. Most manufacturers have standardized on that, which is a 4 times power change, by the way. So when you start listening to signals and seeing them on the S meter, you'll realize what a really strong signal is and what a really weak signal is, and you can interpolate and interpret that by using the S meter. Another control on a receiver is something called the noise blanker. In cars, for example, the spark plug system may generate regular repetitious noises. If you live out in the country, electric fences will send out noise on a regular basis. Noise blankers can eliminate that. It's kind of like a switched squelch. It sees this noise pulse and it will squelch the receiver off just briefly during the noise pulse. And this then becomes a very listenable signal, whereas a signal with all these noise pulses, these high, it's very hard to listen to. So a noise blanker can be your friend in the case of impulse noise. Just know, if you go to a ham fest, some of the old boat anchor receivers that are just filled with vacuum tubes and very heavy, were not the most RF sensitive. Their sensitivity was not what modern receivers are. And so typically they would install this. This is called an RF preamplifier, which would go ahead of a shortwave receiver to make it more sensitive. And you would put it to the approximate frequency range that you're going to operate, and then you would tune it as well. So RF preamplifiers, when you hear the word pre, it's pre or it's before a receiver, preamplifier. All right, we talked about some receiver terms. Let's talk about some transmitter terms. We looked at the mic gain control. There may also be some speech processor settings for compression, which can raise the average power level of your audio signal, which will actually make it louder at distance so that your signal might get through better. And there's also going to be an RF power level control. If you've got a 100-watt radio like this Yaesu, you're going to probably run it at 100 watts all the time. If, however, you're going to be using this radio to run into an RF power amplifier like this, well, the RF power amplifier might not want 100 watts into it. It might only need 20 to 30 watts. So that's where your RF power level for transmit, you can turn it down from 100 watts down to the 20 or 30 watts that this RF linear power amplifier, this is an Elecraft KPA 500, which takes that signal from your transceiver up to the 500 watt level, so to make your signal stronger on the HF band. So this is a high frequency linear power amplifier, also known as an RF power amplifier. They also have power amplifiers for VHF and UHF, generally not to this level, and they look a little different. They look like this. They're sometimes called bricks or power bricks. And the interesting thing about these is that you can use them for FM, and you can also use them for single sideband. But the best settings in the amplifier for FM are not the same as they would be for single sideband. Single sideband requires that you amplify the entirety of the signal that comes into it, whereas with FM, signal amplitude is not important. You just need to make sure you're amplifying the frequency changes. So there's a switch usually on these power bricks right here in the front, which switches between, in this case, FM and single sideband. As I mentioned, single sideband signals require linear amplification of the whole signal, whereas Morse code and FM, they can use something called nonlinear amplification, and the signal will be just fine going out of the amplifier. And when we're talking about signal power, there are two different kinds. There's continuous power, and those are for non-amplitude modulated signals. So for Morse code signals, it's full power all the time when you're transmitting. For FM, for example, it's full power all the time when you're transmitting. But for amplitude modulated signals like AM or single sideband, we talk about peak envelope power. This is an envelope signal over time here, and we look at the peak levels up here. This is, so just know about what kind of modulation you're talking about, and if you hear the term PEP, that's talking about for amplitude modulated signals. And in a block diagram, this is the way a station might typically be hooked up with a transceiver with a linear power amplifier that could be bypassed. There may be a low-pass filter to remove harmonics or spurious signals. There may be a standing wave bridge to tell you about impedance matching on your antenna system. There may be a test antenna, also known as a dummy load. And then your actual antenna is connected via an antenna tuner that provides impedance matching to keep your linear power amplifier happy so that it's looking into what it expects to see. Now, again, we have the RF power control on the transceiver to take it down from 100 watts down to maybe the 20 or 30 watts that a linear amplifier wants to see. If you forget to do that, or if you adjust that control up too high, the amplifier is going to run out of room. It can only amplify up to a certain point, and then it starts distorting. It starts clipping the waveform. And that is not good. That's called overdriving the amplifier. It causes distortion with spurious and harmonic outputs. This is on the frequency domain of a signal here. This is the primary signal. This is what we want to be amplifying. But if it's overdriven, you get all these other spurious signals on harmonic frequencies above the fundamentals. So don't overdrive the amplifier. Know about that. And I mentioned a test antenna, also known as dummy loads. These are great for when you're making adjustments on a radio or an amplifier. You can transmit into, in this case, it's a 50 ohm non-inductive resistor inside of a can, a paint can, filled with mineral oil. And the mineral oil dissipates the heat. It works very well. Or you can make your own out of carbon resistors. This is a much lower power level. And then they make them pre-manufactured. You can find these on Amazon with various connector types. Dummy loads. They're test antennas. We've all got computers, love them or hate them, and computers and ham radio kind of go hand in hand. There's so many uses, including logging contacts, sending and receiving Morse code or digital signals. With the Flex, for example, you can use, it's a software-defined radio, so you can control the radio from your computer. Antenna analyzers will connect up to computers for the display of standing wave ratios or Smith charts. You can operate your station remotely over the internet. Flex was a pioneer in that, for example. And computer sound cards built into computers are used for digital modes such as PSK 31 and other signals as well. And some computers, if they don't have a built-in sound card, you might want to add a radio interface, which is kind of like a sound card in a box, but it also provides push-to-talk control, which is something that we need. For ham radio, we need these three signals. We need audio coming from the radio to the computer. That's for decoding, to understand what's coming back. And then audio from the computer to the radio. That's for coding our message out. And we need push-to-talk to tell the radio to go into the transmit mode at the times that we want it to do it. So you can buy SignalLink or West Mountain Radio. This is one of their adapters. Or if you buy a modern radio like the ICOM 7300 we talked about before, it has a USB connector on the back, and inside the radio is a sound card that does those three functions. It will send audio from the radio to the computer, it will receive audio from the computer to the radio, and it will handle push-to-talk activation. That's the built-in interface on modern radios. Yaesu, Flex, others also have that. So if your radio, standard HF radio, goes from 160 meters up to 6 meters, the 6 meter band, but I want to operate higher. I want to operate on the 2 meter band with my radio. Can I do that? Yes, if you buy this. It's a transverter. A transverter is for both transmit and receive. And what it does typically, this is an Elecraft, is you tune your HF radio to the 10 meter band, and this will, for the 2 meter bands, for example, convert 2 meter signals down to the 10 meter band and convert your 10 meter signals up to the 2 meter band. So it's both for transmit and receive. Transverting, it converts those signals to a different band and make them for 2 meters and 70 centimeters and even into the microwave frequencies. All right, let's answer some more questions. Why should you not set your transmit frequency to be exactly at the edge of an amateur band or subband? Read carefully. C, Charlie, is good.
Oh, D, all the choices.
Yeah, B is good too. Modulation sidebands. If your bandwidth is too wide and you're right at the edge, you're going to be transmitting outside of the band. Also, if there's a calibration error in the transmitter, you don't know how good it is until you've checked it out. So all of those are possible. So what would cause your FM transmission audio to be distorted on voice peaks? I didn't specifically mention that, but yes, you could be over-deviating just by talking too closely to the microphone or too loudly, and the way you can solve that is just by holding the radio further away from your mouth. So what is the purpose of a squelch function? We heard it.
Bravo.
Yes, it's to mute a receiver's audio when signals are not present. And what is an electronic keyer?
Charlie.
Yes, it's a device that assists in the manual or hand sending of Morse code. And what is the effect of excessive microphone gain on single sideband transmissions? What do you think?
Bravo.
Yeah, it will be distorted if you've got the mic gain, it's like that Goldilocks we looked at, too little, too much. If it's too much, you're going to have distorted transmitted audio. And people will tell you, hey, your audio sounds horrible. So which of the following can be used to enter a transceiver's operating frequency?
A, alpha.
Keypad is one, and the VFO knob are both good choices. So how is squelch adjusted so that a weak FM signal could be heard? You turn it off. There is no anti-squelch function, but you turn it off by adjusting the squelch threshold so that the receiver output audio is on all the time. That's the one time when you might not want the squelch to be operating, is if you're listening for a very, very weak signal. And what is a way to enable quick access to a favorite frequency or channel on your transceiver?
B, storing memory.
Yeah, use the memory functions in your radio. And which of the following controls could be used if the voice pitch of a single sideband signal returning to your CQ call seems to be too high or low?
Delta.
That's the receiver incremental tuning, or sometimes known as a clarifier. And we'll be tuning some more single sideband signals as we go along, so you'll be able to hear how it sounds when you're mistuned.
Hey Gary,
Yes.
can we go back to the 1 and 2, the memory channel one?
Yeah.
Did we talk about that? I don't, maybe I was,
Yeah, there are different ways. There are 3 different ways that you can set the frequency in your radio. One is to store it into memory and then recall it back. The other is to use the big knob, and the third is to with the keypad on the radio to put the frequency in. So, yep.
okay.
Yep. And the modern radios have hundreds of memories available. All right. What is the advantage of having multiple receive bandwidth choices on a multi-mode transceiver?
A, alpha.
No.
No?
You're not going to be monitoring a Morse code signal and a single sideband signal at the same time. Go down one. It permits noise or interference reduction by selecting a bandwidth that is matching the mode that you're trying to use. So if you've got single sideband, you want a 3 kilohertz filter. For Morse code, you want maybe a 200 hertz filter. So which of the following receiver filter bandwidths provides the best signal-to-noise ratio for single sideband? From these choices, what would be the best answer? So we know the single sideband signal we've been saying is about 3,000 or 3 kilohertz wide. It can be narrower. So 2,400 hertz would be the best selection here. 5,000 hertz would give you 2 kilohertz of noise, which you don't want. So out of these here, to get intelligible speech, you want to select a 2,400 hertz filter. Can you go back to the multi just for a second there, Bruce? Let me go over here. We're in single sideband here. And notice on the left-hand side there, in fact, I'm going to select one. See, that's 2.9 kilohertz. There's 2.7 kilohertz. There's 2.4 kilohertz. That's selecting a filter bandwidth on the radio to best match a single sideband signal. So that's a perfectly valid thing. All right, let's carry on. What is the result of tuning an FM receiver above or below a signal's frequency? What do you think?
Alpha?
No. For FM, it might be for single sideband.
D?
Yeah, distortion. If you program the radio incorrectly, so that you are for programming for a repeater frequency and you get it slightly off, you might hear a signal, but it's going to be distorted. Distortion of the signal's audio. And which term describes the ability of a receiver to detect the presence of a signal?
Bravo.
Yes, indeed. Sensitivity. And which term describes the ability of a receiver to discriminate between multiple signals?
Charlie.
Yeah, I heard C there. That's right. Selectivity. And what device converts the RF input and output of a transceiver to an entire different band?
Charlie.
Yes, I heard C, Charlie. Yes, transverter. And what is the function of a transceiver's PTT input?
B. Bravo.
So PTT stands for push to talk, and I probably didn't mention that. But yeah, it's two wires that come out to a switch. Maybe it's in the microphone, and when you push that down, the two wires short together, and what it's really doing is grounding a signal control line, and that will take the radio from receive to transmit. Push to talk. And what is the function of the single sideband CW-FM switch on a VHF power brick, power amplifier? Not Charlie.
Bravo.
It is Bravo. You're setting the amplifier for either linear or non-linear amplification. You're setting it for the proper operation in the selected mode. Single sideband requires linear. A CW-FM can use non-linear. And what device increases the transmitted output power from a transceiver?
Bravo.
Yes, an RF power amplifier, typically called also a linear amplifier. And where is, now get this, where is an RF preamplifier installed?
Alpha.
That is for those old tube type radios that were not very sensitive, so you wanted it between the antenna and the receiver so they could hear better. And what can you do if you are told your FM handheld or mobile transceiver is over-deviating?
Delta.
It means you're talking really loudly, or you need to talk farther away from the microphone. And what is the primary purpose of a dummy load?
Alpha.
Bravo.
No, it's alpha. It's to prevent transmitting signals over the air when making tests. If you just want to test your radio or amplifier on transmit, you don't have to connect it to an antenna. You could connect it to a dummy load and make those tests and not bother anybody. So what does a dummy load consist of?
Bravo.
Yes, a non-inductive resistor, 50 ohms, mounted on or in a heatsink. And ladies and gentlemen, you made it now to intermission. You're doing great. Let's take 5 minutes, and we'll come on back and we'll finish the rest of the chapter. Great to have you with us. I want to thank Scott in our Zoom classroom for the comment that he made in the chat that when we were using the Flex radio and we had the radio audio turned up, it was too loud, and apparently it was not. I was not able to talk over it. So using headphones to try to monitor that, but obviously not doing a good job. So what I'm going to be doing from now on is probably asking people if that's a good volume, just so that it's not too much and doesn't drown me out so you lose important information. I apologize for that. So let's get going on section 5.3, which is digital communications. And we looked at packet radio as an early form of digital communications in amateur radio. But even before that was teletype. And teletype got started as a land-based system where you could send text information via landlines, and then radio operators determined how they could use it over the radio frequencies. And we looked at mark and space tones, the frequency shift keying. That's what they came up with. And so the old electromechanical devices like you see here were incorporated into radio transmitting systems as well. So there was an evolution, and the electromechanical became much smaller, and this was a specialized radio teletype modulator system here. Nowadays, software on your personal computer can easily send and receive not only radio teletype, but even Morse code. So we can tell you about some of the names of these programs as we go along. So radio teletype was an early form of digital communications on ham radio. Again, packet radio from the 1970s. So radio teletype was even before that. That was in the 1930s probably. And packet radio, mostly on VHF and above. We mentioned it uses the thing in the middle, the terminal node controller, to go between your computer and your transceiver. A little FM transceiver probably is what's going to be here. And it uses the protocol AX.25. Amateur X25 is what it stands for. And that structure of the data has a header, a checksum for parity checking, the data that is the payload of the message, and then something that uses automatic request for retransmission. If the receiving station gets the packet properly, it will send a signal back, acknowledge. But if it doesn't get the packet as it's transmitted, it will send something back, not acknowledged, or a NAC. And so then the packet system will retransmit the message, the portion of the message that didn't get through. So that's an automatic request to resend. That's a characteristic of packet radio. And packet radio evolved to something we use today called APRS, or the Automatic Packet Reporting System, which also then adds a GPS receiver to the mix. And a specialized TNC that can take that input. And it can also then transmit short text messages via the APRS system. But APRS is sometimes abbreviated as the Automatic Position Reporting System. That's not correct. But if you go to this website, aprs.fi, it will show you a map of amateur radio stations, typically mobile, that have APRS function turned on their mobile radio, and you can watch people drive around maybe in your area. So there may be hams out there that are very near you, and aprs.fi gets all of this information from packet radio repeaters and nodes that ultimately get it to the public internet, where it's collated and put here on the map. So that's APRS, the Automatic Packet Radio System. Email via ham radio, yes, something called WinLink, or Windows messaging over ham radio. you can find more information here at this URL. It uses HF, VHF, and UHF stations. There are gateway stations that are set up that just listen on a certain frequency. And if you want to transmit an email, you set your transceiver to that frequency and you try to connect to the gateway station. And if you make the connection, then you can convey an email message out to the WinLink system and then onward to the public internet. So that is entirely possible. Digital modes on the high frequencies below 30 megahertz, the limit has been to 300 baud symbol rate. So remember that telephone modem we started out looking at there? Well, that's what we're restricted at for the high frequency bands. There have been some changes to this that changes it now to bandwidth, but for our purposes, let's still talk about 300 baud. And so it uses ASCII, the American Standard for Computer Information Interchange. That's an 8-bit code. Radio teletype, on the other hand, because it's much, much older, back from the 1930s, uses something called Baudot. It's a 5-bit code. PACTOR is another kind of a digital mode on the high frequencies. PACTOR 4 is probably the best, most secure, and being used a lot in emergency situations. It uses frequency shift keying, and also remember that automatic repeat request. If data doesn't get through, the receiving station says, send it again, and it will. This is emails, WinLink messaging over radio. And PSK31 was a keyboard-to-keyboard mode, and it was really highly popular. And my friend Dave Ivey and I, we were teaching our classes, ham radio classes, and then a new mode hit the air, and PSK31 died. It's not so popular anymore. FT8 took over. And FT8 uses a software called WSJTX, which is free. And the link is here, and was developed by Joe Taylor and Steve Frank, and it has taken over as the most popular digital data mode. It uses timed sequence, 15 seconds of transmission, 15 seconds of reception, and it can work with very, very weak signals. It trades time for signal strength. So even when bands are dead, when the 11-year sunspot cycle is working against us, FT8 you can still make contacts. And it was first started out using the mode called JT65, which is part of this software for meteor scatter communications. But there are all sorts of different modes that are available in this software. FT8, though, is by far the most popular of them all. And here's some background information about the developers. Joe Taylor is a Nobel Prize-winning physicist from Princeton University. It occupies only 50 hertz of bandwidth. And remember, I said that CW used to be the one that said could go the farthest for the amount of power. FT8 has now taken that crown. However, ham radio operators, well, crotchety older ham radio operators will say, it's not ham radio. It's a contact, not a conversation, and it's true. FT8 transmissions and reception are limited to sending your call sign, sending a signal strength report, sending a Maidenhead locator where you are located, and 73. That's the information that is sent in a contact. But you can't personalize it. You can't talk about other stuff. So old-timers say it's a contact, not a conversation. And some people accuse others of setting up their systems automated. Well, how is FT8 working out for you, says Charlie Brown. Well, my computer is working Asia right now, says Snoopy. Oops. All right, some digital terms to know. Bit error rate, that has to do with the quality of the digital signal. You want the bit error rate to be low. A parity bit is a part of the data that is being transmitted, it's extra data added for error checking. So you can have a certainty that, yeah, okay, the proper data got through. A digipeater could be just a TNC, the terminal node controller. It's a repeater used to relay digital communications through a technique called store and forward. You might connect to a local station and say you want to send it onward to another station. Well, it can be received, stored, and then forwarded on to another station. So that's a digipeater. Node stations are special communications links that allow high-speed transmission of data signals from point A to point B. And then phase shift keying, it's just a modulation mode. PSK31 was that keyboard-to-keyboard communication that was overcome by FT8. A radio...
Gary, question.
Yes, please.
FTA, what makes, I know that it's very low bandwidth, bandwidth, and it can be transmitted all over the world, but why is that more popular than PSK 31?
Come back to me for a second there, Bruce, if you would. So, interestingly, I think it has to do with people who are shy. With an FT8 transmission, it's pretty much anonymous other than your call sign, that you use your mouse and you click on the station that you want to work, and the computer and the radio do all of the rest, and when everything is said and done, okay, boo, you made the contact. I know many graduates of this class who love FT8 simply because they don't have to pick up a microphone, or they don't have to send Morse code. With even PSK31, that's keyboard to keyboard. You have to compose the message. You have to say something. And some people are shy and don't want to do that. And this is the perfect mode for that. And you can work 100 countries on FT8 and get the American Radio Relay League DXCC award for working 100 countries. And so there's room in this hobby for all different types of people. I'm not getting down on anyone. It's just, different strokes for different folks. So that's my answer to that.
Okay.
Yeah.
Thank you.
All right. Some more terms: a radio message server, that's used with the WinLink system. The global positioning system, we know about that. COM ports. A lot of older computers used to use serial data ports, 9-pin and 15-pin connections. Pretty much been replaced by USB connections, but they still exist on some ham radio gear. USB, okay, we talked about that. Gateway stations, providing a connection to the internet from a radio. And then bulletin board systems, they still exist in ham radio, the old BBS systems. All right, did you know that you have a radio in your house right now that is operating on an unlicensed basis, a shared basis, on a ham band? You do, if you have Wi-Fi in your house. The 2.4 gigahertz band is a ham radio band, 13 centimeters. And hams use conventional Wi-Fi routers like this with custom software. And they can set up their own long-range networks on the 2.4 gigahertz band. Hams can go up to 10 watts on these radios, so they can add amplifiers and things. 2.4 gigahertz Wi-Fi is a spread spectrum type of transmission. We won't go into detail on that here in the technician class, but we talk more about it in the general and the extra class. All right, here's some questions. How are the transceiver audio input and output connected in a station configured to operate using FT8? And the key to this one is, do you remember the kind of software I said that they used?
Bravo.
WSJT, JT for Joe Taylor, weak signal Joe Taylor software. So you use the audio input and output of a computer connected to your radio. And what signals are used in a computer radio interface for digital mode operation? What are the signals that you need? We talked about it earlier.
B, Charlie.
Three things, but I can't talk. Receive audio, transmit audio, and PTT, or transmitter keying. Those three things. And which of the following connections is made between a computer and a transceiver to use computer software when operating digital modes? One of the three. We have to get audio from the radio to the computer, and we have to get audio from the computer to the radio. So in this case, the best answer here is you take the transceiver's audio output or speaker connection and run it into the computer's line input audio connection. This is one way you could use a computer sound card for one of the digital modes. Now, most people now have gone to the interfaces or the built-in sound cards in radios. So what is an amateur radio station that connects other amateur stations to the internet? What do we call it?
Alpha.
Yeah, that's a gateway station. And which of the following is a digital communications mode? Read carefully.
Delta.
Yes, indeed. Packet radio is digital. IEEE 802.11, that's Wi-Fi. And FT8, all of those are correct. All of those are digital modes. What kind of data can be transmitted by APRS? Read carefully.
Delta.
Yeah, GPS position data, you can see that on the map, short text messages, and even weather data, the temperature outside, things like that. All of those choices are possible. And which of the following is an application of APRS?
Alpha.
Yes, it's providing real-time tactical communications, the text messages, in conjunction with a map showing the location of stations. What does the abbreviation PSK mean?
Bravo.
Phase shift keying. And which of the following is included in packet radio transmissions? Read carefully.
Delta.
A checksum that permits error correction? Yes. A header that has the call sign of the station to which the information is being sent? Yes. And the automatic repeat request in case of error? Yes. All of those choices go with packet radio. So which of the following operating activities is supported by digital mode software in the WSJTX software suite? Need I say read carefully?
Delta.
Yeah, all of those. It started out for meteor scatter, but then they did Earth, Moon, Earth, and then weak signal propagation beacons. I didn't cover that, but yeah, all of those choices. The WSJTX software suite, which is free, it's a fascinating piece of equipment, software. All right, what is an ARQ transmission system?
C.
Automatic repeat request or automatic request to retransmit. Yes, it's an error correction method in which the receiving station detects errors and says, oh, I didn't get that right, using parity and things like that, and sends a request again for retransmission. And which of the following best describes an amateur radio mesh network? Oh, I didn't maybe use that term, but maybe you can puzzle it out. Think Wi-Fi. With those modified Wi-Fi routers with custom software. And it's an amateur radio-based data network that might be existing in your neighborhood. It's not connected to the internet. It's completely separate, but it contains the same kind of TCP/IP traffic. What is FT8?
Bravo.
It's a mode, a digital mode that could be used during the bad years of the sunspot cycle when bands are closed down. So it's a digital mode capable of low signal to noise operation. So come back to me just for a second there, Bruce, if you would. I had a question here in the YouTube chat asking about is Pactor 4 being used with the WinLink? I don't know for a fact, but I would have to say no. Pactor 4 is a proprietary system of data communications, which is now being allowed on the amateur radio frequency bands. Great for disaster and emergency communications. However, the Pactor 4 modems themselves are about $2,000. And so not everybody can afford that. And WinLink is you can get software, you can download software to interface to your radio to then get into the WinLink system. So I think they have their own independent software base for that. And maybe they use Pactor 4 for some links or something like that. Disaster communications, Red Cross assisting them and things like that, that's where Pactor 4 shines. All right, let's go on to section 5.4, batteries and power supplies. And some radios have built-in power supplies. They just plug into 120 volts AC. I am the proud owner of a new ICOM IC7760. It's the ICOM radio's new top-of-the-line radio they just released a few weeks ago. It has a built-in power supply. You just take the AC cord, plug it into the wall, and everything else is done. Now this is a 200-watt radio, so they're probably not operating at 12 volts. They're probably operating inside of 50 or some other volt in there to get the higher output power. So some radios do have built-in power supplies, but most amateur radio transceivers are what we call 12-volt radios, or they operate on 13.8 volts DC. That's the convention. So you need a power supply to convert house current from 120 volts AC down to 13.8 volts DC. So you're going to need one of these probably to power your radio. And there are two different kinds of power supplies. Conventional, also known as a linear power supply, uses the big, heavy, bulky transformers to step down 120 volts down to a lower voltage, and then regulator systems to get it down to 13.8 volts DC. They're noise-free as far as radio frequency noise. A lot of hams love linear or conventional power supplies. But the new kid on the block are the switching power supplies. This Elenco was an early version, but there are a bunch of more out there now. They actually take the 120 volts AC and chop it up to a very high frequency, 20 kilohertz to 50 kilohertz, and use small, very lightweight transformers to bring it down to 12 volts and then filter it. These things are really lightweight, so it's 20, 30 pounds on one side and 5 pounds on the other. So switching power supplies have some advantages. And if you're going to be operating a VHF or UHF radio, originally designed maybe for the car, but you're going to bring it into the house, you want a power supply that can supply at least 15 amps. Now, if you're going to go on HF, those are 100-watt radios. Well, there you're going to probably need 30 amps, a power supply that'll supply 30 amps. And so if you go to Ham Radio Supply or DX Engineering or Gigaparts or Main Radio or some of the other amateur radio suppliers, R&L, power supplies. These are the things you want to look for. And they're all going to be regulated so that they keep the output voltage constant at 13.8 volts. Don't do what Gary did. Come back to me for a second, Bruce. So I cheaped out. Not with a ham radio transceiver, but I had a TV camera system at my old house, and it was a 12-volt based system, and I wanted to put a power supply to power all of my cameras rather than using like 6 different wall warts, which is what they gave you. And so I said, okay, I'm going to get a big supply, and I'm going to wire it so that I can power the security cameras, and I'll be happy about that. But I didn't want to pay the price for an American Astron power supply or some of the other brands. And so what I did is I found a power supply on Amazon. And I looked at the ratings and I said, well, this should do. Cheap Chinese power supplies. You get what you pay for. So you can take a look here on the laptop. This is what I bought. It looked good. 16 amp mobile supply, 13.8 volts, regulated. It worked fine for about 2 weeks. Then the regulators shorted out, and instead of putting 12 volts to my cameras, it put 21 volts to the cameras and fried them all. So a power supply, what my point is really important in your station. Don't cheap out. Get a good one. And if you don't know what a good one is, ask a friend or somebody in the local ham club, and they'll steer you right. Don't buy on price. You will regret it, I can tell you. All right. Car batteries, the lead acid batteries that are in your car, they're nominally about 13.8 volts when they're charging. So that's where that comes from. And it charges from the vehicle's alternator. And when it is charging, did you know this? You're releasing explosive gas, hydrogen, and that hydrogen gas has to be vented. And if you charge too fast, you can release high levels of this hydrogen gas. So this is something that you need to keep in mind. Now, for cars, it's not a problem because they're whizzing down the highway and it just goes out into the atmosphere. But if you're in a controlled area, closed area, and you're charging batteries and whatnot, you might have a fire hazard there. So you need to be aware of that. Also, when you're driving down the highway with your car's got lots of noise sources built in. That alternator that we talked about, if you put a mobile radio in your car that's not an FM radio but an AM or a single sideband radio, then you can hear amplitude fluctuations. And then you'll start hearing alternator whine or spark plug popping. You'll hear problems with grounding in the vehicle. You can have all sorts of different things. When you hook up the power to your radio, you always want to connect all the way back to the battery, as close to that as possible, and also the negative as well, so that you eliminate a lot of noise that might be coming from the body of the vehicle. And there may be a current sensor on the battery negative in your car, so that may impact where you ground the power lead from the mobile radio. Again, if you don't know what you're doing, find somebody who does, or a friend in the ham club that can help you out. Batteries, just be aware that some batteries may be recharged, some batteries not so much. Carbon zinc batteries. I remember back in the day, they used to sell these on the backs of magazine. You can recharge your flashlight batteries. No, you can't. They're not rechargeable. But starting with nickel cadmium batteries and lithium batteries, lithium iron phosphate, many of those are rechargeable. So just know the difference. And this table is in your book as well. And lithium iron phosphate batteries, if you ever picked up a lead acid battery, they're heavy. Oh man, you strain to try to pick it up. These are lightweight, especially for the amount of capacity that they have. They do require a special charger to make sure that they're charged properly, and they're rated in amp hours. So here's a 100 amp hour battery, And you can tell what the running time of the battery is going to be if you know what the average current draw of your radio is. And if you know that, you can take the amp hours divided by the average current, and it should give you the run time of the particular battery. Field Day, Amateur Radio Field Day, the last full weekend in June, you may find going on in your area. Your local ham club would love you to come out and participate. They're powering their radios typically by generators, sometimes by batteries, sometimes by inverters. Just know about them and know that the capacity of the generator. How big should they be? Well, you need to calculate the RF output stage's efficiency. You're going to use more power in transmit than you are in receiving, and the idle currents and things like that. You need to keep up on that and to know what size generator you need. Also, when you're wiring your radios, wire has something called ampacity, the amount of current that can be safely transmitted through that wire, and it varies by the gauge of wire. So larger wire can transmit more current. The thing is, we're trying to minimize voltage drops along the power cables there. If you start out at 13.8 volts DC, you want close to 13.8 volts at the other end. But if your wire is too small, you're going to start heating that wire, and the voltage will be less at the far end. So you want to minimize what we call voltage drop. All right, here's some more questions. Which of the following is an appropriate power supply rating for a typical 50-watt output mobile FM transceiver? I gave you some numbers. What's the closest one? So for a VHF or UHF mobile radio, I said 15 amps. They say 12 amps. So, okay, that's the closest one. So 13.8 volts at 12 amps. Why are short, heavy gauge wires used for transceivers' DC power connections?
Alpha.
Yeah, we're trying to minimize voltage drop, trying to keep 13.8 volts at both ends. And how can you determine the length of time that equipment can be powered from a battery?
Bravo.
Yeah, divide the battery's ampere hour rating by the average current draw of the equipment, and that'll give you the amount of time. All right, where should the negative power return of a mobile transceiver be connected in a vehicle?
Alpha.
Yeah, you want to go back to the battery if at all possible. Used to be that you could connect to any metal part of the vehicle. That's not so much anymore in modern cars. And which of the following battery chemistries is rechargeable?
Delta.
So nickel metal hydride, yes. Lithium ion, yes. Lead acid, yes. All of those. And which of the following battery chemistries is not rechargeable?
Bravo.
Yeah, carbon zinc, the old flashlight batteries. No, you can't recharge those. And what type of circuit controls the amount of voltage from a power supply?
Alpha.
Yeah, well, that's what failed in my cheap Chinese power supply, the regulator. So what hazard is caused by charging or discharging a battery too quickly?
Alpha.
Outgassing, that hydrogen gas, and even heating then. All right? And that, ladies and gentlemen, is the end of Chapter 5 But I want to provide you with these URLs because we are over halfway through the class now. And here are 3 websites where you can go to review test questions. And we recommend the top one, the American Radio Relay League's exam review. But there's also hamstudy.org and QRZ.com, for example. They have practice tests that you can use. You're almost ready for those. But if you can go here to the ARRL's website, you can sign up for a free account, and then you can go and review the questions we have already talked about in the previous 5 chapters, or 4 of those chapters had test questions. And so you want to be reviewing, you want to be renewing, remembering what we talked about so that you can retain it long enough to get into the test session and know the right answer. So this is all part of the human learning process and remembering process. So this is the website that we recommend. It's free. You will probably have to give them your email address only to establish a free account, and that way they keep track of how your progress is, and they'll tell you what your strengths and weaknesses are. So that, ladies and gentlemen, is the end of the class tonight. Let me go ahead and close out, if my cursor will move here.
Gary, question.
Yeah.
What would be the advantage of going online like this versus, I thought the book had all the test questions and answers. Is it just that it tells you strengths and weaknesses, or?
Yes, and you can actually then go online and select the chapters that you want to review. So you can select chapters 2, 3, 4, and 5, which we've covered right now. And so it won't give you anything that we haven't covered yet. So this is just to help you in the remembering process. Any other comments or questions?
Thank you very much.
You betcha. All right.
Yeah, this is good.
All right. So we will see you next week for your chapter 6. Until then, let me say 73. Take care.
73.
Kevin threes.